All right, guys. So today's video, we're going to be doing some introduction to all the proof rules we're going to be using for the next couple days. So this will kind of depend on how much you remember, how long this video will take you. So the first thing I'm going to ask you to do, I'm just going to do one. I'm going to demonstrate one for you. Here's what I want you to do. I'm going to pause in a minute, and you are too. So the first thing, the property or postulate we've talked a little bit about is the reflexive property. It's when a quantity is congruent to itself. So the way we visualize that the last couple days when we were doing those little mini proof examples was if something had a shared side. So if I have that triangle with that shared side down the middle, I can use the reflexive property to say that BD, this side here, is congruent to itself. So if we're trying to prove triangles are congruent and we need three pieces of information, that shared side is going to be really common to be one of our three pieces of information. So what I want you to do is go down the list here. Substitution property, the addition and subtraction postulates, those are ones that you may not remember. We haven't done them that much. But I want you to try to draw a picture of all the ones that you remember. There should be quite a few that you remember what they look like. All right, so take a few minutes, get them all done. And like I said, the more you get done now, the less you'll have to kind of watch the video later. So I'm going to pause, and then when you unpause, I'm going to have all these done so we can go through the ones that you need help with. All right, so please pause now. I'm just going to wait a few seconds for you to do that. Pause now if you haven't. All right, try this out on your own, see what you remember. Don't just wait for me. Okay, so hopefully you all paused and you tried some out and now you have unpaused. So looking down our list here, the substitution property, the way I kind of referred to this earlier in the year is if like I owe Mr. Clinton $1 and Mr. Clinton owes Mrs. Techman $1, then I might as well give my $1 right to Mrs. Techman. So in proofs, you're going to see it with segments and angles, obviously. So like if I say in this picture, if AB is congruent to BC, and BC is also congruent to CD, then I know I can kind of take out the middleman. I can connect the dots. I can say AB must be congruent to CD. Without a doubt, it has to be true. A way that I've seen some teachers show this, which is really neat, is if you see like two things that are both congruent to different things, so if those BCs show up in both of my congruencies, I can assume that the other two, the AB and the CD, must be congruent to each other. All right, so that's the substitution property. If you guys need to pause to write things down, I'm going to go quick because I already have them written down. I don't want to make this video too long, but if you need to pause and write things down that you have left blank, you need to do that. You are going to have access to these notes. These are all the rules you're going to need. So the better you write them down, the more accurate you are, the better you're going to be in the long run. All right, the addition and subtraction postulate. Basically, the whole is equal to the sum of its parts. So like an example I think we looked at earlier in the year, if I have like a few different angles here, if I have these two little pieces here and here are 10, and this overlapping kind of piece in the middle is 20, then here's what we talked about. We said, let me do this with my magic pen, actually, this will make it look easier. I know this angle here, 10 plus 20 is 30. So that whole angle there is 30. But I can also do the other side of this. I can add these two angles together. So that 10 plus 20 has to equal 30. So these two overlapping angles, because they kind of have these similar parts that are all equal to each other, if I add those little parts together, it gives me two equal 30-degree angles. So that one's a little harder to see. Same thing with the subtraction postulate. So I showed the subtraction postulate here with segments. So it works the same way, just going backwards. So if I kind of know this whole overlapping part is 4, and this little middle part is 1, this is actually another example of the reflexive property, then we know just by all the math we've done throughout our whole life, we know that's 3 and we know that's 3. So if we have two bigger parts that are the same, and we kind of subtract out a part in the middle that's the same, then those two little leftover pieces have to also be the same. All right, hopefully we got the next 3. We spent a lot of time earlier in the year on these. A midpoint. B is my midpoint. It cuts a segment into 2 equal parts. A segment bisector. So if CE, this line right here, if CE is my segment bisector, then it tells me that the two pieces that are being bisected, basically, AD and DB, it tells me those two pieces are congruent. So we had a question like this early in the year. Notice it doesn't tell me that these two pieces are congruent, right? So we have to read really carefully which thing is doing the bisecting. So that's an important example to kind of clarify. We sure should know what an angle bisector is. The words are literally right in the definition. So an angle bisector cuts an angle into two equal parts. And we haven't done a lot of this in a while, but please refresh yourself. We have to be able to communicate really clearly together on how to name angles. So ABD and CBD. All right, remember the vertex is always the middle letter when you're naming angles. So that's angle ABD right there in purple. And that's angle CBD right there in my yellow. And recall, if those give you trouble naming them like that, you can always just put a 1 and a 2 in there, and you can say angle 1 is congruent to angle 2. But an angle bisector cuts an angle into two equal parts. Vertical angles, same thing. We should absolutely know what those are. You're going to see those a lot, and the word I use for these are bow tie proofs. We're going to be doing some proofs where we have to do two triangles like this congruent to each other. We had a bunch of these last week. Whenever you have a bow tie proof, you should always be on the lookout for those vertical angles as one of your three parts. So remember, your three parts are leading us to the SSS, the SAS, the ASA, the AAS, and then our bonus rule, the HL. So those are the things we're looking for, and vertical angles are going to be a big help for that. Okay, pause, rewind, guys, please, 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 if you need to. I don't want this video to be too long, because I'm going quick. Next page, little more familiar, hopefully, some of these. Linear pairs, always add to 180. So you may have drawn a different picture. I guess I should have mentioned that. If you have different pictures, you don't have to erase and redo yours, but these are just here for you for a guide if you didn't know what to draw. Two angles next to each other, always equal 180 degrees that are off of a straight line like that. A big issue I've seen people have is trying to make these congruent. So if this is 100, there's no way that can be 100 as well. All right, that would be too many. That would add up to past our 180 degrees. Now there is one case where they are congruent, and that case is if the angles are both equal to 90. So if I kind of extend this line, there's my 180 degrees. And if these are a linear pair, if one of them is 90, then the other one also has to be 90. So that's what perpendicular lines are. They form 90-degree right angles. And then another thing we haven't really talked about at all, but this is going to be another piece of our proofs that we have to talk about. You're going to see these two things linked together all the time. So I would put a little star. Those are grouped together. So when we do these proofs, if you see something in the proof tell you about perpendicular lines with our symbol that looks like this, you're going to tell me that, okay, perpendicular lines make right angles. And if I have right angles, I know those two angles have to be congruent. So we know if something is equal to 90 degrees and another thing's equal to 90 degrees, those two things have to be congruent. So again, going back to our proofs, you don't have to draw this triangle I'm writing now. But one of our three pieces of a proof might be those 90-degree angles. All right. Parallel lines. We know our symbol for parallel is this. These are going to come up a lot, so you have to know your relationships. Hopefully we were able to draw those. We had this big project that we did earlier using our roadmap. So we have our parallel lines cut by a transversal. Alternate interior angles are congruent. So the greens match up and the reds match up. Alternate exterior angles are congruent. All right, so again, pause if you need to. Corresponding angles are congruent. So the corresponding, there's a lot more going on. Just be really careful. You don't have to mark them all in, but my red marks with my red, my green match with the green, etc. The corresponding angles, if you remember, like the way I thought about it was what corner are they in? So this red angle is kind of in the top right corner of this intersection, and it matches with the one in the top right corner of that intersection. So corresponding angles are also congruent. And an important thing to note, this works both ways. So I'm going to just kind of show on the side here. I'm going to work backwards on one. So basically, if I know the lines are parallel, so if I'm given that information, now this unlocks all my good angle rules. I can say, okay, the lines are parallel. So that tells me these alternate interior angles must be congruent. But sometimes we're going to be asked to prove lines are parallel. So let's say this is what they give us in a picture, and they put these two angles are congruent. So now I can say, I don't know those lines are parallel yet because they didn't tell me, they don't have the arrows on them. But if these alternate exterior angles are matching, which they are, it forces the lines to be parallel. So we can kind of prove parallel lines by using the angles. We can also prove the angles by using the parallel lines. It kind of goes both ways. Okay, so we're going to talk about that a lot more too. Isosceles triangles and base angles, you sure should have this one marked in. This is what we just spent the last couple weeks on, but there's a nice picture of it. If the sides are congruent, it tells me the angles opposite them are congruent, and that works every single time, no matter what. All right, so I'm going to pause for a second and see where I'm at. If you needed to go back and rewind and rewrite any of these, please do that now. Okay, so here's what I want you to do for homework tonight. First of all, obviously do all the notes. I would like you to take a picture of your notes and upload them to this assignment so I know you wrote everything down. And the last thing I want you to do is brainstorm this question number one. Think about what you know, think about the strategies that you can use, and try to prove that these two angles are congruent given this information. So really what I think about is we're lawyers, we're cops, we're trying to use the evidence to link these two things together. So the important things that we're going to talk a lot about, first of all, is mark your diagram. It seems really simple, but people who don't do that, who get lazy, who try to go too quick, seem to have a lot of trouble with proofs. So when I mean mark your diagram, I mean we know angles 1 and 2 are congruent. So I'm going to mark those with those congruent angle markers. Okay? And the other thing that I always recommend to people is to look at what we're trying to prove. So in this case, we're trying to prove angle 1 is congruent to angle 3. So I'm not going to mark these in like this because I don't know those are true. I don't want to mark it in as congruent because I don't know they're congruent. So what I like to do is I take a little highlighter, or with my with my smartboard, I can just do this. Just shade it in a little bit. Try to give yourself a visual about what you're trying to do, what angles you're trying to connect, or whatever we're trying to do. All right, so brainstorm this question a little bit, get a couple thoughts down on paper. I'm going to put a Google form out to you guys to get this done. And other than that, I'll be here if you need help, but I will talk to you guys next time. See you.